Hello my friends, this is video 49. I'm almost done with the 40s, and unfortunately what comes next are the 50s, and those are just more Fs. So, today we are talking about the properties of exponentials, and then we will talk about solving exponential equations, which are equations where the variable is in the exponent. So let's get started. As far as properties go, everything that you know about working with exponents applies here. You all know that if I have x to the third times x to the fifth, that's x to the eighth because you add exponents. And if I have x to the second to the third power, I multiply. And if I have something that's being divided, then I subtract exponents. All of those rules apply. Absolutely nothing changes. Absolutely nothing changes. And as long as you don't think too hard, you'll be fine. So if we look at something like 3 to the x plus 2 times 3 to the 2x minus 1. If these were two variables, we would do what we did here, which is copy the bases and add the exponents. Okay? Over here, I copy the bases and I add the exponents. So 3, 3, 3, x plus 2 plus 2x minus 1. And then I just collect like terms. This is going to be 3 to the 3x plus 1, and I'm done. Okay? Nothing has changed from what we already know. Same thing with division. Over here, I would copy the base and subtract the exponents. Same idea. Copy the base and subtract exponents. Now I need to subtract the whole exponent from the denominator. So I need parentheses, but after that I can change signs and add, and then collect like terms. This is going to be 3 to the negative 2x minus 3. So as far as properties go, absolutely nothing has changed from what we know already. Okay? I'm going to give you two more properties that are going to help us solve equations. The first property says that if I have a base to some power, and that's equal to a base to another power, then I can drop the bases and just look at the exponents. And this is a function of the fact that exponentials are one-to-one functions. So the only way that this works is if the exponents are the same. And this is the property that we will use to solve a lot of exponential equations, because it will allow us to drop the base so long as the bases are the same. And we'll look at an example of that in a second. Another variation on this theme is that if I have a number raised to some power equals a different number raised to that same power, this is only true if those two numbers are the same. Okay? And x is an odd number. If it's even, it's a different story. But if it's odd, we are good to go. Okay? So this will let us drop exponents and just look at the bases if they're the same and odd. Okay? So let's look at some examples of this in action. Let's look at 2 to the 2x minus 1 equals 2 to the x plus 2. Okay? Because these two bases are the same, I can do like they do in the dub step and drop the bases. And then I can just solve this equation as it is. And I get my answer. Okay? If the bases are the same, I can drop them and look at the exponents. Okay? Another example. Now, what if the bases aren't the same? Sometimes they aren't, and we're kind of hosed. And we'll need to use a logarithm in those cases. We won't look at that right now. What we'll look at are situations where the bases appear to not be the same. One is a 5 and one is a 25. However, if you think about it, I can write 25 as a power of 5. I can write 25 as 5 squared. So I can rewrite this so that the bases are the same. The question is, what's going to happen between this 2 and this stuff here? Well, does it help you if I write it this way to see what you should do? If I write it this way, you can clearly see that we need to multiply. Now, once you see that, you can skip that step and go right from here to multiplying it out. And at this point, the bases are the same. I can drop them like they're hot and solve what's left. So plus 2x plus 2x, 3x minus 2 equals 8, plus 2 plus 2, 3x equals 10, divide by 3, x is 10/3. Okay? One last thing and then I'll let you go. What the heck are you supposed to do with 1/9? Remember, if the bases aren't the same, we want to try to rewrite them so that they are the same. So how can I write 1/9 as 3 to a power? 9 is 3 squared, but I don't have 9, I have 1/9. Does anyone remember what we were supposed to do? Excellent. I'm glad that you said that. I can write 1/9 as 3 to the negative 2. 1/9 is 3 to the negative 2. Multiplying these two exponents out, I can now drop my bases and solve what's left. Plus 2x plus 2x, 5x minus 1 equals 4, plus 5 plus 1 plus 1, 5x equals 5. Ooh, look at that, x is 1. That's handy. That's really handy. Okay? All right. So if it's an exponential, get the bases to be the same. Now, there's a problem in that what if you can't get the bases to be the same? Like in this case, and we'll talk about techniques that you can use to deal with a situation like this. But for the moment, that won't come up. So if it's an exponential, get your bases to be the same. Okay? That's all for now. I'm done. Have a great day, and I'll see you later. Bye-bye.